I'm Max Boykoff, Center Director here. Doing the intro to the intro, where Matt will be introducing Charlotte Chang here in a minute. I just want to pop up, because there's a few new faces here, encourage you all to please keep coming back. We got all these Noontime seminars, which are a lot of fun, generate some great conversations, especially today is going to be an excellent one. Next week, we have our next one. A.R. Siders is visiting. Cassandra Brooks, who's a professor here, is hosting that visit. So, and then take a look online. Amy Naku-Schmidt here, who does our outreach and engagement, has a good list of people up there. So, thanks a lot for coming along.
Cool. Well, thank you all. It's my pleasure to introduce Dr. Charlotte Chang, who comes to us from NIMBIOS in University of Tennessee. Before that, she did her PhD at Princeton. Like me, she's a theoretical ecologist turned social scientist. So we're kindred spirits, and she's been offered the Chancellor's Fellowship, which means that she could be our colleague soon. So we're very excited to have her. We hope that she stays forever, and we hope that you all enjoy her talk.
Thank you all for coming, and thanks so much, especially to all the students for being here. I know how busy it is this time of year. I'm really touched that you are willing to take time out of your busy schedules to come listen to my work. So I'm excited to talk to you today. This is a very conservation science flavored talk. That is one of the primary hats that I wear. One of the ways I market myself is as a conservation social scientist. And this is a photo I took at my field site in southwest China. It's a pretty intact secondary forest. I was motivated to work there after my undergraduate experience doing a Fulbright in eastern China, which is a pretty boring landscape, very low species richness, salt marsh, you sink in the mud. I was trying to study nests, classic avian ecology projects. Realized that by doing my transects, I was actually leading to the deaths of the nests because you break the reed bed open and then the raptors fly through and they're like, there's lunch. Here we go. All right. But the really unfortunate thing, I pivoted to working in the only part of mainland China that's tropical forests. This is in Yunnan province on the border with Myanmar and Laos. And it's this beautiful lowland tropical jungle ecosystem. But what you can't tell from this photo, which I took during a bird transect, is that it's a totally silent, empty forest. Scott Robinson, a renowned tropical ornithologist at the University of Florida, came to my field site as a distinguished speaker, invited by the Chinese Academy of Sciences, and he said this was the most silent forest he'd ever seen, the most fruitful he'd ever seen on the ground, indicative of the complete loss of the fauna in this region. So this leads me to the kind of broader set of issues that face us as conservation biologists or as environmental scientists, which is that biodiversity globally is in crisis. The Living Planet Index, compiled by the World Wildlife Fund, shows that since the 1970s, from our best case estimates for species that are well studied, we have on average lost 60% of the population abundance in most species. And this trend is only projected to continue into the future. So this poses several immediate questions. What is the scope of this problem? Where is it most intensely distributed? And what are the threats that are driving this issue? And at the same time, we know that since the 1500s, we've lost extensive alpha diversity across multiple sites. And we have extinction rates that are, orders of magnitude higher than background extinction rates. So if we think about where threats are located around the world, we tend to see images like this. So if we think about one prominent social covariate, which is the degree of poverty, areas that are more impoverished are highlighted. Oh, sorry, I guess the laser pointer doesn't reflect. But areas that are more impoverished are more yellow. Areas with more species richness and more threat are more blue. Where they intersect, you see those intense purples and reds. And not surprisingly, a lot of this threat is concentrated near the equator in tropical regions. So then this also leads to several questions. Is there a concrete relationship, a causal relationship between poverty and biodiversity? Is it like a correlation that's driven by other factors? Is this pattern indicative of a certain level and factor of threat that's distinct from other areas of the globe, from the temperate and extratropical regions? And I posit that there are certain threats that are really distinctive to the tropical region. And one is that as that previous graph shows, there's a high degree of poverty in these areas. And that has led to high reliance on non-domestic sources of protein. So best estimates across major tropical basins, from the Congo Basin to the Amazon Basin to insular and continental Southeast Asia, estimate that for rural communities, people living in these conditions may get as much as 80 to 90% of their protein from wild bushmeat. So this poses immediate needs and challenges for conserving biodiversity. And indeed, a recent study by the International Union for the Conservation of Nature, IUCN, shows that for well-studied taxa, overexploitation, so excessive logging, excessive hunting, excessive fishing, remains one of the primary threats to the persistence of these species. So I've worked on this particular type of issue through the lens of coupled natural and human systems. This is a framework that's shared by many of your colleagues here at the University of Colorado Boulder, and I've applied this in these tropical landscapes. So we can think about the fact that you have these faunal assemblages that have their own ecological processes, for instance, at the level of individual populations of a species, population dynamics, growth, migration, emigration, and then they are affected by human activities. And in turn, those human activities are dictated by the interaction between individual decisions to harvest or not, for instance, to harvest at some level of intensity, to use certain forms of gear or other forms of gear, which are also informed by the larger social context in which these individuals find themselves. Community level social norms, for instance, and group level beliefs. So these all have cascading effects and interact with one another. And one problem that makes studying these systems really complex in these tropical ecosystems is that often activities like hunting or logging certain species or fishing in inland streams, especially if you do blast fishing, for instance, are criminalized. So that obtaining the necessary social data is inherently challenging. Like measuring accurately, do you hunt or do you not hunt? Have you logged this species of rosewood or have you not? People have a strong incentive to be dishonest and to not tell you the truth. So that adds another layer of complexity into the equation. So today I'll be talking about several projects that examine resource harvesting through this coupled natural human systems lens. And I'll be starting off with talking about how we can measure compliance with conservation regulations, which kind of goes into that sensitivity issue. How we can link harvester decisions with ecological outcomes, especially in these systems where they're harvesting tens of species and we have really poor social and ecological data often. I'll talk about the pervasiveness of harvesting as a threat to tropical systems. This is a collaboration with Matt that's ongoing, and we're hoping to wrap it up soon, so any thoughts, really welcome. And I'll close with a few projects that were actually led by really talented undergraduates, developing tools to improve management under uncertainty and in cooperation with local communities. And then I'll end with speaking about some future directions for the projects that I proposed that would take me here to Colorado. So I'll start off with this first part of my work, which looks at conservation compliance, and I want to acknowledge these two super bright undergraduate researchers, Li Yuzhao and Zhu Xiaoming, who heroically collected a bunch of survey data. What you don't see is in the background, I was picking beans because the villagers told me that if they're going to waste their time answering survey questions, someone has to go pick beans for them. So, this is like a tertiary crop. They primarily tap rubber, but you know, a hustle's a hustle, so someone's got to do it. So I worked in China for most of my dissertation. That was my primary field system. And I specifically worked in Yunnan province, which is highlighted in red. And then I worked in Xishuangbanna state, which is one of these areas in China that has extremely high biodiversity and cultural diversity. It's an ethnic minority majority region. And this inset map shows you the layout of Xishuangbanna. The green areas are protected areas. And really the rest of this state has been extensively deforested for rubber monoculture, which is pretty inhospitable for the native floral and faunal assemblages. And I'd like to acknowledge my amazing field crew. They made all this work possible, and my collaborators in China, Professor Chen and Professor Chang, who were really awesome. So to measure compliance with conservation regulations, so specifically in China, there's laws prohibiting the ownership of firearms. Not very surprising, it is an authoritarian regime. They're not really stoked about private citizens owning guns. And there's a variety of rules that make hunting native wildlife illegal, especially with a gun. So gun already bad. And then hunting certain species is illegal. They have an equivalent of the U.S. Endangered Species Act. It's called the Wildlife Protection Law of 1988. It was directly inspired by the ESA. U.S. scientists in the Fish and Wildlife Service have been really instrumental in capacity building and providing international collaboration to bolster that law. There's also laws that restrict the entry into protected areas, and because of the extensive deforestation, where are you going to find these native birds, especially these, these phasianids, these very forest-sensitive species? You're going to find them in the protected areas, which are technically illegal for even researchers to enter. So you can imagine that if you're going to go in there, and be up to no good, that's like extra illegal. So we did these surveys. The two undergraduates, Li Yuezhao and Zhu Xiaoming, measured these responses across 20 villages, interviewing 200 adult men, and asked them, in the past year, have you hunted bulbul? Have you hunted partridge? Have you hunted pheasant? Have you hunted barbet? And we had example photos to help ensure that the recall was good in these cases. So we used a survey technique that was developed by political scientists and sociologists seeking to measure stigmatized behaviors, such as, do you endorse this racist candidate, or are you, for instance, HIV positive, where people have a strong incentive to not tell some random researcher yes, if it is indeed true. And I'll describe on the next slide how this process proceeds. And then we compared it with traditional direct question, where I just go up and I'll be like, hey, Matt, did you shoot that partridge yesterday in the field? No, never. I mean, this is not my gun. I don't even, what's a bird? I don't even know what a bird is. I literally never do anything like that. How could I even do that? So we deployed the randomized response technique, which kind of turns these types of questions, these binary questions, yes, no questions, into a game. And the premise is that you get a dice, you roll it. If it lands on 1, you're forced to say yes. If it lands on 6, you're forced to say no, and otherwise you answer honestly. And you observe it privately. So I'd say, Steve, please roll the die. Don't let me see it, and then give me the answer. So if Steve says, yes, I hunted a barbet, I don't know if he truly hunted it or if he was forced to by the die. So the premise is that by offering this degree of anonymity and masking the yes, in this case, a sensitive yes response, that it should hopefully lead to more accurate prevalence estimates of these stigmatized traits. But the problem is you then can't take the 1s and 0s at face value, right? You record yeses and nos, and I can't say oh my gosh, I got 80 yeses, all right, so I know the prevalence is 80 over 200, done. Because we know that some proportion of those yeses were forced and are not dishonest, but were forced. So what we can do is we can use a statistical estimation procedure where we know the probabilities of being forced to say yes if you were a non-hunter, designated by this backpacker in the upper right-hand corner, given the probability of a die roll, an unbiased die roll, that should be 1 out of 6 occasions, and otherwise you should typically be answering no, and vice versa if you are truly a hunter. So I developed a software package in R to help conservation practitioners analyze these types of data in collaboration with a sociological methodologist. And what we got out of these estimates using that software package was estimates of the prevalence of hunting for those 4 bird species. And we weren't sure if hunting was still happening in this landscape. It is pretty defaunated. I mean, is there even a point going out there with your gun and potentially getting arrested by the forestry police? I don't know. So on the x-axis, there's those 4 bird species. On the y-axis, it's the prevalence of hunting. And what we observed is that indeed there is still hunting for these relatively rare species of partridge and pheasant. Those point estimates are pretty low. Not a ton of people hunted them in the past year. That doesn't mean that they didn't have the intent to hunt. What we saw for bulbul, which is the most common taxa of birds in these very impacted forests, is a fairly high prevalence of hunting. On average, 1 in 3 adult men are going out and shooting this bird, which suggests to me that actually hunting is still prevalent in this landscape because all those other species are more desirable. If I was a hunter, I see this little dinky dude, but then I see a nice pheasant walk by, you know what I'm saying? I got priorities. I want the pheasant. The problem is pheasants are exceedingly rare and hard to shoot at. So the success rates are probably low, but again, not the ideation and intent to hunt. So that's a big complicating factor in interpreting these types of data. And another thing that we'd often like to know in going forward and proceeding with designing conservation interventions that actually speak to the local problem, given that we have localized survey data, is identifying, okay, there's people who hunt, there's also people who don't hunt, right? Given that bulbul estimate, the majority of adult men actually are not hunting at present. So what is distinguishing people who are still hunting, given the really low reward of hunting in this landscape? And using a multi-model inference approach with those response data, we measured a ton of covariates like ethnicity, age, all these other standard per capita income, all these other standard covariates that are very financially oriented. We also measured psychometric or attitudinal correlates. And what we found was that attitudes really matter in this landscape. Unfortunately, there's not really a clear directional impact. It's probably because I don't have super high statistical power given the number of respondents that I had and this approach, which tends to reduce your power because you have some degree of respondents classification. But by pooling information across all 4 birds in the estimator that I developed, we were able to find that actually these attitudes are really important. So to successfully enact conservation, if we do indeed care about reducing poaching pressure on these birds and other taxa, any successful conservation intervention can't just hit the pocketbook of these hunters. We also have to change hearts and minds. We have to change the perception, for instance, that hunting is a very enjoyable activity, or we need to offer an alternative form of recreation. Maybe skeet shooting, for instance. That would be hard. China doesn't want its local people to have guns, but something similar to absorb that level of recreation. And what's nice about my landscape is that I don't have to worry about some of the humanitarian welfare elements that other tropical biologists have to worry about, because in the course of my survey work, it became abundantly clear that rubber smallholding has lifted people out of poverty. There were families who owned Mercedes-Benz, being like SUVs, and made more money than the director of the field station that I worked at. So it's not driven by poverty. It really is driven by these cultural-oriented values and the thrill of the hunt, the thrill of the chase, the ability to get outside of the house and be like, bye dudes, gonna go up in the forest for a few days, see you later, you annoyed me, all right, I'm gonna go hang out with my buds. Okay, so the next part of my work thought about how hunting affects communities, and one major issue that affects all tropical biologists in many systems, given the prevalence of hunting around the world, is that hunting in these landscapes is extremely speciose. So there's been studies that have ethnographic studies, I really commend them, 2-3 years in the field in parts of, say, rural Amazonia, and they catalog like 100, 150 species that are killed, from a tiny hummingbird all the way up to a really large tapir, like the largest extant mammal left after the Pleistocene overkill. So this presents immediate challenges for conservation science. At a very bare minimum, I'd like to have some confidence in knowing these taxa are hunted, these are not. This is how we can triage our limited resources for conservation. The problem is, when talking about hunting is already sensitive, and you can't really always get representative samples, how can we actually accurately identify the full scope of species that might be subject to hunting pressure? And this really matters because we know that around the world, megafauna are the most at risk of endangerment and extinction. We know that size is a really strong predictor of extinction risk. And this little infographic helps back that up from the perspective of mammals, from like a tiny little bamboo rat all the way up to a rhinoceros, or from a tiny little bulbul all the way up to this ibis. And that matters because size in the tropical systems is often correlated with important ecological functions. So we know that the largest bodied birds and mammals play important roles in seed dispersal. Carolina Bello and her collaborators showed that the loss of the largest birds and the largest mammals in fragments of the Atlantic forest has led to ecological meltdowns and altered forest recruitment dynamics over time, with implications for reduced carbon stock. So this is an issue that also cascades into other contemporary biodiversity conservation threats. At the same time, the largest animals are often critically important as ecosystem engineers. For instance, you have hippos or rhinos that make forage more nutritious for mesoherbivores that create new habitats for other species and dramatically alter the hydrology of the local systems or the fire ecology of the systems in which they inhabit. So to answer that previous question, how do we think about what taxa are subject to hunting pressure and what taxa are exempt? One way that we can do that is by collapsing all these individual species down to a trait that hunters care about. And in most of the tropics, that trait is body mass. Sometimes it might be ornamentation, or for the cage bird trait, it might be singing ability. This is a huge issue in Indonesia, where the forests are being emptied of all songbirds even. They are just trapped and then traded for expensive songbird singing competitions. And unfortunately, it's like a cut flower trade. Many of the birds die in transit because they're hard to keep alive. But if we think about a hunter's choice, if they're looking at a community of species, each species might have some mean body mass, shown on the x-axis on a log scale. And then hunters might have some preference that they assign on average to these species. And maybe they most prefer the largest, and then they least prefer the smallest, right? So if we think about starting to disentangle which species are subject to hunting pressure and which species aren't, we want to know where that cutoff lies, right? Like, is it true that the little tiny bulbul and tailor bird in the bottom corner are going to be free from hunting pressure, so we don't really have to worry about this process affecting those species? And what that would mean is that there's something equivalent to what economists call a reservation value, or what we ecologists might think about as a trait threshold in separating who gets hunted and who is ignored by a hunter. So what's really nice is we can actually adapt a pretty lightweight theory, search theory from microeconomics. There's optimal foraging theory, but that's pretty parameter intensive, and it's hard to measure those parameters in these systems when hunting's criminalized. You can't really ask someone who doesn't want to talk to you about hunting how much time it takes them to butcher a carcass. So you can't get handling time estimates. But there's different approaches from other fields. And I adapted search theory from microeconomics, and at its core, if you think about from the perspective of a hunter, I'm watching different birds or I'm watching different mammals walk by, and I have a decision to take a shot or not at every observation. Well, everything has some trait value. This is some arbitrary unit. This is some value that I assign to the species. It could be monetary, it could be caloric, or energetic. And then that means that there's going to be some utility gain from waiting. So if I see a bulbul and I bank my shot for something else, I'm likely to see something better, given the probability density of species in this landscape, for instance. If, however, I see a pheasant and I let it walk by, I'm unlikely to get another draw, another observation of a species that has a higher trait value, right? So this is going to help me dictate where I should set my trait threshold, where I should shoot. And specifically, if we zoom into some arbitrary region, let's say I'm a hunter and I really like game birds, I have some opportunity costs that I pay for my time going into the forest, right? Like in my landscape, I could always be rubber tapping instead. Or I could always be doing something else with my time. Picking beans, for instance, as I so gloriously got to pick beans very poorly. I was told my bean picking technique was not very strong. Don't really know what it means to have strong bean picking technique, but maybe someday I'll learn. So what that means is we can take that and draw out where the opportunity cost intersects with that utility gain from waiting curve, that marginal utility of another observation curve. And where that falls out is going to give me my trait value or my reservation value. So in this case, if I see something that's bigger than that emerald dove, I should shoot it. If I see something smaller than the emerald dove, I should bank my shot and wait. I can afford to wait. It's a critical distinction. So just to give you a sense of what the community looks like in southwest China, on the x-axis, this is showing you body mass, the mean body mass for these species from the Pantheria database that was developed by Kate Jones and others on a log base. And on the y-axis, that's showing you the density of each of the observations that I drew doing my bird and mammal transect data. So we see a large dominance of really small birds and no mammals other than muntjac and boar. We know that these are some of the most resilient mammals left, right? They're invasive species around the world. Wild boar are a huge issue across the American West and the American South. Muntjac are invasive. The small Asiatic barking deer, also called muntjac, they're invasive in the United Kingdom. So these are really like the mammals that are left after everything else was hunted out. No more sun bears. No more river otters. No more felids. It's a pretty, and no more gaur, which is the Asiatic wild bovid. So it's pretty bad. But applying that model from earlier, I measured the opportunity cost of going hunting from my social data, my previous social data, the cost of people's labor time, and there's some range for that. The typical hunting trip is a 2-day foray into the forest, and I know what the foregone wages are from the social data. And what each of these colors is showing you is the dietary threshold, that if I was a hunter and say my opportunity cost was, say 10 units, then I should be shooting something around, I don't know, somewhere between, 10 grams to 20 kilograms. So some wide variation. I think it is about, if I remember correctly, around like 20 kilograms here. So something bigger than a muntjac, I should take my shot, right? And what's interesting to note is that as your opportunity cost goes up, you should actually be less selective. Those colors are going from blue on the left, right? So the poor people can afford to wait, right? The cost of their time is less valuable. They can afford to draw more observations and wait to take a good shot. Whereas people who have more money should be a little less selective. This is a core tenet of this theory. It kind of falls out from the original search theory predictions. But what's really interesting is that all these regions in gray are regions where, given the current trait density, given the current distribution of animals that are left in this area, it doesn't make sense to hunt. Like, your time is too valuable, dude. What are you doing, right? Like, just don't go. It doesn't make sense for you to hunt anymore. Like, do other things with your time, man. It only makes sense if you place like a ridiculously disproportionate value on prey. So we estimated bushmeat values from black market data that I collected in China. And these values are pretty skewed because the only people who sell bushmeat on the black market in China are really poor hunters in Laos and Myanmar. So they sell it at rates that are lower than their Chinese counterparts. Chinese hunters have ways of they either consume it themselves because they really value it, they value wild meat, or they're selling it through informal networks and they have ways to get higher market value or intangible value, like they're buying their way out of a police sentence. Like, hey buddy, don't arrest me for this one infraction, here's some muntjac meat. There you go. And that just saved me from like $1,000 R&B fine and days of jail sentencing or something like that. So what we were covering is that, well, eventually maybe it makes sense for you to hunt, but you just have to have a ridiculous valuation of your prey relative to our best guess estimate. So going forward, we often want to think about how hunting, as it's currently practiced, will impact ecological communities. This is a major, outstanding question in thinking about the management of this threat around the tropics and around the world, especially given how little regulation there is in practice on the ground. So even in China, which is maybe one of the best cases of top-down enforcement, in reality, you have like the forestry police going out twice a year. They're not going to catch anyone that way, and relying on paid tip-offs. So what that means is people just retaliate and say, oh, my neighbor, I don't really like what Amy was doing yesterday. I saw Amy poaching. I just want to let you know. I'm ready for my payments now. So the social data that we can often gather from the approaches that I presented earlier are things like the prevalence of hunting. So this is denoted by the term pi. This is coming from the political science and sociology literature. They like to denote their point estimates of binomial proportions with the term pi. It doesn't mean profit, as it means in economics. And then people who aren't hunting are denoted by 1 minus pi. And if we want to think about, okay, so we have this whole, faunal assemblage of species that are potentially subject to hunting pressure, what's going to happen? Are we going to lose the largest bodied species? Or are we going to just be left with the really tiny guys? And this process has been called by folks like Rodolfo Jutso at Stanford the ratification of the world. It's pretty depressing, yeah. The ratification of East Africa, the ratification of Southeast Asia. Pretty depressing and documented time after time after time. But what we lack is a theoretical understanding of how this process is proceeding and an ability to capture these impacts, anticipate these impacts from minimal social data. So what I'm doing in collaboration with Matt and a quantitative ecologist at the University of Tennessee, Singli Guillaume, is I've compiled a literature synthesis on hunting prevalence and the social dimensions of hunting across more than 100 sites in the tropics, 116 sites specifically. And what you can observe is that hunting is pretty common, at all these sites. We see it everywhere from Central America all the way over to Southeast Asia. And I calculated across all these sites that the median prevalence of hunting is about 39% of households engaged in hunting. So we can combine these types of prevalence estimates and roll them into statistical models, and then leverage raster-based social data, such as human population density and other economic covariates, to think about the potential impacts of hunting. So how do we project the impacts of hunting, right? To do this, I have leveraged super simple theory that falls out of population dynamics. So if we think about any, population, over time it has some process where it might start out from some really, really small non-zero abundance, and it will initially grow quite rapidly, and then it'll level out as it approaches carrying capacity, right? Like good old like introductory ecology, population dynamics, logistic growth. And what I can do is I can take this expression for the rate of change for any population, which is given by its maximum per capita population growth rate, multiplied by its abundance, and then subject to some correction as it approaches the carrying capacity. We don't want things to grow infinitely and be protecting elephants all over the world, a planet of hundreds of millions of billions of elephants. That doesn't really make sense given what we know about their biology. And then I can add in a term that represents the removal of individuals in a population or in a species by hunting. And the nice thing about this super simple approach is that it maps back to the level of social data that I was able to compile from these reports. So these are pretty standard metrics that researchers can fairly easily measure with existing survey techniques and given existing levels of trust in these low conservation governance regions. So I can represent the rate of removal the rate of hunting removal as a product of human population density, the prevalence of hunting, and then a term that tells me something about, for every hunter, how many animals are they removing? What is the per capita mortality rate that's going on in these regions? And that's something that some of these very detailed ethnographic studies have estimated. Love them. Thank God for them. It's so amazing that people spent like 2 or 3 years in the field painstakingly gathering all these measurements. So from that simple model, we have a condition for extinction. And then we can take this and we can derive something about the maximum body mass that can persist under this hunting process using the social covariate data that I'm able to estimate. So it's not necessarily, it doesn't necessarily hold for all time. Like hunting itself is a time evolving process. You know, it's not a stationary process. But we know that, for instance, the intrinsic rate of growth scales negatively with body mass, right? Like elephants produce less offspring than a tiny little rodent, right? Like a big, beautiful Asian hornbill produces less chicks on average than like a tiny little tailor bird, for instance, which might have more clutches per year and more eggs per clutch. So we can just use standard allometric scaling exponents to think about how hunting, as I can best estimate it around the tropics, would lead to limits on the body mass of animals that can persist under current levels of hunting. And what I did is I took those 116 sites, I took IUCN data, polygon data, so shapefile data, on the current distribution of mammals. And what these green box plots show you is the distribution of the largest size species that are present in each of those sites in the Afrotropics, Asian tropics, and Neotropics. And it's on a log scale. So this starts at 1 kilogram and it goes up to about 4,500 kilograms in the case of the Afrotropics. And then I was able to project with the current set of social covariate data that I estimated and using raster data from sources like NASA's CDAC, what that might look like for body mass of species that can persist under this level of harvesting pressure, given current population densities, and then UN estimates for human population densities in 2050. And what I'd like you to observe is that this simple model just predicts that there will continue to be declines in the largest body size of species that can persist under hunting pressure. So this kind of emphasizes from a different perspective the statistical analyses done by folks at IUCN and other institutions that have shown empirically that large body size is correlated with threat. This says that if we take a deterministic approach, we also see the same results with the best social data that we have at present. We can always have better social data. I always welcome that. I think that'd be fantastic. But at present, with the best that we have, we can already underscore and enhance those claims. And then we can take those types of raster data and that scaling rule that I mentioned before and project what body mass might look like if hunting processes continued as currently estimated. So huge caveats here, right? Only have 116 sites. It's not as though it's as rigorous as human population density estimates. But what we see is that across the tropics, we stand to lose megafauna from many regions. And meso and microfauna are represented by the blue and greenish yellowish colors. So again, on the log scale, the blue colors mean that given my best estimates, we might hunt things down to things that are only a few kilograms, like a 10 kilogram tiny duiker in East Africa, or a 17 kilogram muntjac in Southeast Asia, for instance. So that leaves us with a set of challenges, but we'd like to improve management. And as I mentioned before, we have these complex moving pieces. We have the fauna that are being targeted. We have the human communities and the harvesters within these communities that are making decisions. And one major problem, as I mentioned, is that tropical systems tend to be extremely data poor. We don't have great social data. We certainly have, on average, pretty poor ecological data as well. So this is research that was led by undergraduates to think about both fostering greater cooperation. So what's the scope for communities to take the path forward, to lead the way in encouraging conservation of their shared resources? Oftentimes, even when you have these top-down rules, there's a lot of corruption and a lot of reasons why the central government might not be very effective at enforcing rules. We're used to pretty good enforcement here in the U.S. It's unfortunately not true even in a police state like China. That's not, the wildlife don't get to enjoy the benefits of a police state. And the other tool that the undergraduates that I've worked with have developed is a decision tool to help tropical managers dealing with co-harvested species. So to think about this first project, this was led by 3 undergraduates, Kevin DeAngeli, Ibasi Iman, and Alan Gen. And they created a simulation model using many of the approaches that Dan Doak and his collaborators developed, matrix population models of species that are subject to harvesting pressure. And they helped make this useful for managers who have rough parameter estimates and are managing both wildlife that are hunted and trees that are targeted for non-timber forest products. So what I mean by that is trees where, for instance, we gather the fruits, we might gather part of the bark, we might take some of the leaves, but these are sublethal effects. You know, there might be some detriment to the survival of the adult stage class from like climbing up the tree and getting the fruits, and you know, you might kick into it, you might cut it a bit to like create a bit of a step ladder to get up there, but you're not doing the same thing as logging. You're not removing, you know, the logs from the forest. So it's a different process than that type of removal. And it's pretty common throughout the tropics. In my field site, people harvest different fruits, they harvest different medicinal compounds from forbs and trees. And this is applied to the case of the agouti in Brazil and the Brazil nut tree also in Brazil. So Kevin, Iman, and Alan, or Kia for short, like the charismatic New Zealand parrot, developed a simulation model that tracks a population of trees as they transition from being seedlings. There's some rate at which they remain a seedling. They eventually become saplings. They remain saplings at some rate. Then they eventually transition to becoming adults. And the adults are affected by harvesting at some sublethal rate. You know, they're not completely killed by the harvest process, but it might affect their long-term survival. And the adults contribute to the population of seedlings through germination and seed production. Now they're coupled with the seed disperser because the seed disperser is critical for the seedling emergence from the seed stage. We know that this is pretty critical. Folks like Josh Tewksbury, who has now come here, in a past life, he did really cool work showing how birds eating chilies, for instance, help promote the germination of chilies by passage through the gut. So the bird's flying and pooping, and that helps chili seed germination. A pretty elegant set of studies and like a really cool process. And then we combine this with a discrete time simulation of hunting pressure. So absent a really good descriptive process of how hunting and harvesting is proceeding, again, didn't really have social data in hand for any system. Kevin, Iman, and Alan identified standard rates that they could estimate for Brazil nut and agouti, years of high harvest versus low harvest, represented by mortality to agouti and the Brazil nut adult stage class trees from the literature, and then you simulate that in a Markov chain process and you apply that into this model approach. And they've developed a tool that can help managers visualize what's going to happen to the target taxa when they have different parameter values that are known for these species and different rates of harvesting, perhaps from best guess estimates or from field data that the manager may be collecting. So one example of output that they generated is if you look at different rates of adult survival for a given tree species, and you look at different rates of germination, when you have some background rate of harvesting and some background rate of population growth for the seed disperser, you have a range given in red where the tree is going to be doing all right, and then a range given in blue where the tree would be declining. And similarly, you can also identify thresholds in hunting pressure where hunting would no longer be sustainable from the perspective of just keeping these species around, keeping the populations present in the landscape. So this is a really cool project that they accomplished within a 12-week time span. Super productive little beasts. They were awesome. It was amazing. And they made a GitHub repository. Another project was led by a Princeton undergraduate who I advised for a thesis. She is a early career young geographer and interested in rural sociology, and she wanted to work in Sichuan and understand why some communities choose to conserve these little tiny patches of forest. So as I mentioned, there's extensive deforestation for different, like row crops and tree crops, but they often also conserve, some of these communities often also conserve little patches of forest for different purposes, like water provisioning services or ancestral worship services. And what she did is she did surveys across all of Sichuan. She measured, if I remember correctly, I think 300 villagers, and she measured different metrics for economic capital in yellow, social capital in purple, and environmental capital in green, and she related this to their willingness to participate in different forms of land conservation. I don't have time to go into those results today, but I'd be happy to talk about them with anyone who's interested. And she also measured local communities' views on top-down, government-led forest conservation versus bottom-up community-led forest conservation. And it was pretty intriguing for us. She found that generally villages are much more willing to participate in community-led conservation. If the government were to step in and say, "Hey, we're going to take this area that you were going to use for farming, and we're going to turn it into a forest preserve," they would demand compensation more often, or they would just outright refuse to participate to the best of their ability. Again, not really a democratic country, so things are different. Or there's a sense of resignation that I would just be forced to do it, and I don't really want to do it, but I'd have to accept it. So this was a pretty interesting set of findings that helps inform how conservation organizations in the region can proceed to better build bridges between the Forestry Bureau and local communities. So local communities don't feel like, well, you know what, screw you, I'm just going to burn the edge of the forest, whatever. I'm not even going to plant anything there, I'm just going to burn the edge of the forest because you pissed me off. I've also worked on separate projects with Kriti Karant of the Center for Wildlife Studies and Wildlife Conservation Society on habitat specialist responses to agroforests in India. And I've worked with Chang, my main collaborator in China, on habitat specialist bird responses to rubber forests. And unfortunately, what we found in China is that rubber forest is not really good secondary habitat for forest-dependent bird species. In fact, we saw no endemic or IUCN red-listed species. In India, we found a much more hopeful story where, to our great surprise, one form of coffee production, Robusta is often hailed as a really negative form of coffee production. But because of historical legacy reasons, it's often grown under shade trees in southern India because of coffee rust, which is a major pathogen. And it's actually pretty good secondary habitat for habitat specialists. And it's preferred as a crop by smallholder farmers because it's relatively easy to set up. It's not as capital intensive as Arabica. And there's more shared knowledge in the region on how to grow highly desirable Robusta strains. So this was a pretty surprising result for us. We were really happy when it came out. And it's been great to work with Kriti to roll this out into ongoing coffee certification schemes that she's heading up in the region. It's always great to do that. And in a different project, I'm working with operations researchers and resource economists on improving reserve site selection algorithms, good old, systematic conservation prioritization, park selection, what have you. There's different terms for this. And we've applied the most simple model, but we've brought in the fact that when we set aside areas for conservation, we also have to include the long-term costs for enforcement and monitoring. And indeed, those costs might dwarf the initial acquisition cost of the land, particularly so in the tropics. So we're applying this to a set of data from Colombia, looking at different species. Shown here, this is rasterized data that has presence-absence. With our best estimates of land costs and enforcement cost data, the enforcement cost data is not shown. And what you can see is when you approach this problem from different perspectives, you come up with different outcomes. And indeed, if you think from the outset about the fact that you both have to purchase the land and you have to potentially enforce it, and you can purchase, or you can also purchase and enforce the parcels that you choose to conserve, you get different biodiversity conservation outcomes. And this tends to be the most efficient when you have these types of threats in the landscape. You can use a lot of benefits when you have other mindsets going into this approach. So I'm really excited to work with Max and Matt on a project that we proposed. It's a bit of a pivot for me, but through my work there's always been a strong thread and a strong element of thinking about the social dimensions of how humans relate to the environment. And the next step in my own evolution as a researcher is applying this type of perspective to social media data. So our colleagues in political science and sociology have done amazing things looking at environmental posts to think about, sentiments around climate change, the fact that, for instance, conservatives may have more negative sentiments about climate change legislation through tweet data, for instance, or economists who have calculated the amenity value of staying in a certain temperature band. They've calculated sentiment on different degree days of heat, and they've shown actually we could stand to lose a lot of amenity value in the US given current warming trends. And I want to apply this type of approach to a broader set of environmental topics that has not yet been done despite the wealth of data in this sphere. So if we think about it, the conceptual models, we might have different issues that people are talking about, different actions that they're mentioning, like say, oh, I went hiking, or oh, I donated money, or oh, I went on a trash pickup, or oh, I read this piece of policy, or oh, I feel this way and that way. And they might have different values in terms of, say, sentiment or polarity on different scales that can be measured using computer science techniques. And indeed, using just some super preliminary exploration of these data sources, we see differences in the terms that are used by Republicans versus liberals from our best guess estimates from political science methods applied to Twitter data that I harvested. We see engagement with environmental posts in China. This is much more preliminary work on my part, but it's encouraging to see that there is potential scope to apply these methods to a different society where this work is really underdone. And also looking at the user base, we see, for instance, a high diversity in different psychological correlates or psychological, what is it? Personality traits. Yeah, the big five: openness, conscientiousness, agreeableness, neuroticism. We see some distribution across the respondents that I found, that I harvested from these via API queries. And we also see, for instance, looking at Twitter data, a pretty good spread of more left-leaning and more right-leaning respondents. So pretty confident that we'll be able to parse out some interesting trends from these data. I'll also be working with Matt to develop some mathematical theory around recovering cooperation in groups that hate each other. This is a major question. And it's not just a problem in the US. I'm sad to report that this is increasingly a problem in China. It's increasingly a problem in India. It's increasingly a problem in the Philippines. Like, you know, my heart is really in Asia. I really want to improve conservation practice on the ground, and this is also a major issue there. The rich-poor divide, the rural-urban divide, divides along religious views, divides along ethnic identity. These are not just problems that we face in Western democracies. Indeed, they transcend borders, unfortunately. And this is work that will be done in collaboration with several conservation organizations, something that I'm really passionate about, is ensuring that my research has practical impact. So really excited about this project. Welcome any thoughts that you have. I'd like to acknowledge all of my amazing collaborators, my funding sources, my mentees, and thank you all so much for your time. Any questions? Or?
I was just wondering if you could chat a little bit about something I'm really interested in. You mentioned it when you were talking about the motivations for hunting in the region that you work.
Yeah.
And so you had mentioned that it was sort of less driven by property and a little bit more
Yes.
driven by various cultural factors. And so I was wondering if you might be able to sort of maybe speak, just based on your experience, to maybe tease that apart a little bit. Like, is it about identity, or is it about, you said there was maybe a recreation aspect? Are those really different?
Yeah,
So
absolutely.
I wonder if you could speak a little bit more about that.
Absolutely. No, I think they are totally different. When you're totally right that when hunting is primarily driven by social norms or cultural identification, there can be a really strong moral and ethical argument, especially say for indigenous populations, to continue these traditional practices and to keep, you know, their traditional identities alive. I actually suspect that in this landscape, it's not primarily that; it's more the thrill of shooting at something, because the birds that are harvested are not used in any traditional regalia. Like, they don't. It's not like parts of Indonesia where they take hornbill feathers and casks and they, you know, fashion decorative items out of them, like sheaths for swords or decorative hats. In this region, it really is like, hey, I got this bird and I stewed it, woo! You know, it's like kind of fun, you know. They feel like, oh my god, it was so small, it was really hard to shoot, and I got it, you know, like, oh, I did it. So I think it is in some ways very similar to aspects of resource use that predated the North American model of conservation, like a fee-based approach to conserving natural resources and working in partnership with local communities to educate them on the importance of maintaining robust, healthy populations so that they have that amenity value of, you know, enough individuals can counter the field and shoot. And in fact, maybe in North America, it's because hunting is declining, we have kind of the opposite problem where we should probably have higher hunting pressure. And some hunters are like, no, you can't trick me. I want to keep, you know, the big bucks around. I'm not going to hunt the does. We kind of have the opposite problem in China, but certainly around the world, like hunting, it's a really diverse practice. There are regions where it really is primarily driven by poverty and subsistence needs. And then in that case, there's ways that I think you can manage that to make it more sustainable. You can encourage hunting to target very resilient stocks. So like go after bamboo rats, go after like dikers, things that have pretty high Rmax values, and monitor that pretty carefully. Try not to use like gear that has a lot of bycatch. This is something that fisheries folks have thought about very deeply, something that's a little less mature in my field. Shooting is in many cases less bad than, for instance, net hunting, because net hunting is how you get really rare endangered species as bycatch that you encounter at low rates. But if you have this static trap, you know, they'll eventually get sampled, for lack of a better term. So yes, absolutely. From my field set, I think this is a general process that is driving the maintenance of hunting and is informing how hunting is shifting with rising incomes across Southeast Asia. I think this is pretty general for anywhere from China all the way down to Indonesia and all the way west to, say, Myanmar. I don't think it is as true for parts of South Asia. I think for parts of Northeast India, that's kind of true, though there's more cultural practices embedded there. And then actually much of India has pretty low rates of hunting. There's a high cultural tolerance for wildlife. But I think it's a very different process in the Afrotropics and the Neotropics. Though there are certainly elements of this too, like in the Atlantic forests. Yeah.
So how much do you feel that government policy surrounding firearms
Yeah.
plays into this thrill of the hunt?
Oh, I think a lot. That's a fantastic question. I actually think a lot, right? If you make it illegal and you don't have any mechanism where people could, where local people could pay a fee and could engage in a highly regulated form of gun-based recreation, whether that's stalking game birds. I mean, there are estimates that show that that's actually pretty inefficient, pretty bad from the perspective of like carbon emissions. But if you could at least like shoot skeet, that would be one option, right? So I do think that's a major part of the issue. I've talked to my partners in China, and the best thing that we've been able to come up with is thinking about pride campaigns to try to near term shift some of that hunting pressure away from the most vulnerable species. I think if they're going to poach and go after muntjac and boar,
How prevalent are laser tag?
Unfortunately not as much. They love karaoke. I worked really closely with hunters. I couldn't have done this field work without my field assistants who are all hunters. There's not the same infrastructure for field support that there is in the Neotropics or even parts of South Asia where there's a longer history of formalized tropical research. In China, it's pretty ad hoc. So I worked with hunters and they brought me on their trails. And yeah, like I know their personal lives pretty well as a result, and they love karaoke, they love gambling games. I mean, I really think it could be gamified. I think laser tag actually could be a good approach. It's just that I can't publish that. I didn't even ever make it through peer review. I had to use pride campaigns to get it in the discussion section. But yes, this is actually something I talked about with my collaborators, like gamifying it. Introducing like laser tag and or like games with exactly, or like the Cabela's big game hunting kind of software thing. Yeah. And definitely, I think the younger generations are to some extent hunting at lower rates. I think the problem is that people who do hunt are super hardcore and super good, and then effectively not regulated by anyone or anything. But many of them are, they're stuck like we are, like stuck into their smartphones, and they're increasingly urbanizing lives. Yeah.
We have an online question.
Oh, great.
Through your work, are you familiar with any examples of dramatic declines in overexploitation following intentional interventions of some kind or even unintentional local, cultural, economic disruption?
Yeah, absolutely. So I think the case in point for this, which is really depressing, is the uplisting of species on IUCN Red List. Dave Williams, who actually works with David Tillman, so 1 degree of separation from Matt Burgess, published, I believe it was Dave Williams who published a paper with IUCN colleagues that showed that when a species is uplisted, there is statistical evidence that poaching pressure increases near term. Yeah, because it's a market signal, right? It's actually like a pretty accurate signal that, hey, the experts think this guy is getting more rare, and I'm gonna go out there and I'm gonna harvest it. I haven't seen the same degree of, or really any evidence of negative rebounding effects from like pride campaigns or community outreach campaigns. What I have seen is sometimes evidence that they haven't achieved anything, unfortunately. Although there was a case in Thailand where WCS Thailand, led by Rob Steinmetz, used these types of pride campaigns and pre-post social surveys with ecological surveys and showed that stocks actually recovered. So in the right context, you can have these very localized conservation campaigns make a positive impact. But of course, yes, there's absolutely negative rebounding impacts that we don't want, and there is evidence that they happen. There's also evidence that the current rates of purchasing ivory are driven by a really small proportion, for instance, of Chinese consumers who see it as an investment in extinction. So telling them that elephants are going to go extinct maybe has the opposite consequence because they think, yeah, this is a great investment. It's going to skyrocket in value. So, yeah. Yeah.
Wondering what you think about economic policy instruments to deal with this, like payments for ecosystem services, paying them not to hunt. Yeah. In particular, in relation to kind of the implication of as rising there's incomes rise. Yeah. You take out more of the megafauna. Yeah. Yeah. So I think that's a fantastic question. It really gets at the heart of like the contemporary arena of research around resource exploitation in the tropics that's headed up by people from resource economics all the way to like rural sociologists to folks like me who kind of sit in the middle and are original trained ecologists. And there's evidence, for instance, that in areas where it's primarily subsistence-based hunting, like the neotropics or part of the afrotropics, PES can be really powerful and can help absorb some of the worst hunting pressure and let people pursue domestic alternatives to protein. So they can take that income and they can then go to the market and buy chickens, right? And that often works best when
wild meat is considered an inferior good to domestic meat. Now the problem in Asia is that it's not. Or I should say like East and parts of Southeast Asia is that I don't see evidence that wild meat is an inferior good. I think if anything it's maybe superior good. So I think that conservation interventions, recognizing this aspect of the psychology that drives hunting and consumer behavior, you need to make your alternative activity or your alternative way to absorb their income have a lot of social prestige and cachet, like clubify it. And this is actually what we successfully did in North America, where we made, for instance, regulated white-tailed deer hunting part of a club. This was like the original Pennsylvania clubs that regulated hunting. They've gamified it. They made it more fun to be a member of the club and to follow these rules that were originally perceived as very onerous. And that was more fun than being outside in the cold and like doing your own thing, kind of being lame and not getting to hang out in the lodge with your bros. So I think my intuition is that in Asia, any successful resource exploitation intervention is going to have some cachet of like fancy and shiny, blingy kind of thing. Yeah. Any other questions? All right. Well, thank you guys for your time. And feel free to email me anytime if any questions ever arise, or visit my website.